This problem is an example of plotting the specific energy diagram and also determining the two possible depths of flow of a rectangular channel or the alternate depths of flow for a specific energy and for a given discharge. So first, we have to list down all the given and illustrate the problem. So we have a rectangular channel and the depth of the rectangular channel. We have depth y and the width is equal to 1.6 meters. We have Q, which is equal to 4 cubic meter per second, and the specific energy, which is also equal to 2.5. So first, we will find the two possible depth or the alternate depths of flow, and also the plotting of the specific energy diagram. Okay, this is what we're gonna do in this problem. Okay, plot the specific energy diagram. Okay. Okay, we will solve first the unit discharge. So the unit discharge is equal to Q over B. That is the discharge per meter width of the channel, and that is 4 divided by 1.6, and that is equal to 2.5 cubic meter per second per meter width of the channel. Then, okay, this is the Q. Then we have to get the specific energy, and that is equal to Y plus V squared over 2G. So we have Y. The velocity for the rectangular channel is also equal to Q squared over Y squared. So we have divided by 2Y, and that can be equal to Y plus Q squared over 2G Y squared, where Q is equal to 2.5 squared divided by 2G Y squared. We can simplify this. So our Y, or our specific energy, will be equal to Y plus, okay, we have 2.5 divided by 2.5 squared divided by 2 divided by 9.81, and that is equal to 0.319 over Y squared. So this will be our equation 1 for our specific energy. We will also compute the depth at critical condition. So at critical condition, the critical depth YC for a rectangular channel, we have cube root of Q squared over G. This formula is only for rectangular channel. You have to take note of that. Okay, we have Q, which is 2.5 squared divided by 9.81. So that is equal to 2.5 squared divided by 9.81. So cube root, that is equal to 0.860. Okay, 0.860 meters. Okay, so we have here now our critical depth. So we can also compute our minimum energy. Okay, for the minimum energy, in terms of the depth, we have, or for the critical depth, we have 3/2 yc. And that is only for rectangular channels. So you have 3/2 times 0.860. So our energy or minimum energy is equal to 3 divided by 2 times 0.86. That is equal to 1.29 meters. 1.29 meters. So this is also equal to critical energy. Critical energy or minimum energy are the same. Okay, so we have now our data here. Next, we have to plot this one, and we can also, okay, since we have, so before plotting, we have to solve first the depth of flow, the two alternate depths of flow, since our energy there is given. So let's try. Okay, we will plot the data after we all determine what we need, no, in the plotting. Okay, so here, since E is equal to 2.5, so 2.5 meters, so we have there from equation 1, okay, from equation 1, okay, we have from equation 1, we have 2.5 is equal to y plus 0.319 over y squared. Okay, so we can have this by using trial and error, or we can get the value of our y using your calculator, using shift solve formula, and we also compute this using cubic equation. So since here our y, if we will simplify this one, this will be in the form of cubic equation. So okay, so we have here, we can have this one, we have to multiply all the equation by y squared. So we have now 2.5 y squared, okay, is equal to y cubed plus 0.319. So we will make this into an equation to be equal to 0. So with this will be, we will transpose 2.5 to the right, and that is negative 2.5 y squared plus 0.319, which is also equal to 0. So we have here a cubic equation. So we have 3 roots for our y. So we have 3 depths of flow here, but the 2 depths are positive and the other one is negative. Since negative has no physical meaning, So we have to only consider the depths that are positive. So if we are going to use your calculator using shift solve, okay, you can shift solve using the calculator, and okay, you can also use the trial and error. Okay, you can use trial and error. Then you can also using the cubic equation formula. Okay, formula, which is equal to ax cubed plus bx squared plus cx plus d equal to 0. So by solving y, we can have y is equal to, or you can also use what you have learned, the formula, what you have learned in the numerical method. So upon solving the y, the roots are, okay, thus y is equal to 2.45 meters, and this is also, okay, 2.45, okay, 2.447. I have to use 3 decimal places, meters, then 0.338 meters, and the other one is negative 0.335 meters. Okay, we will not use this one because there's no physical meaning of the negative value. We cannot use the negative value, only these two depths that we are going to use. Therefore, the two possible depths of flow are y is equal to 2.447 meters and y is 0.338 meters. This is belong to upper stage, and this one belongs to lower stage. So this is our answer. Next, we will plot our specific energy, and we have here, so for example, this is our y, and that is in meters, and this will be our e, and that is also in meters. Okay, we have here 1 2 3 4. We let that one as our 1 2 3 4. This is 2 1 2 3 4, and this is our 3 sorry, that is our 3 meters. Then we have 1 2 3 4. This is our 1 1 2 3 4. This is 2 1 2 3 4. This is 3 1 2 3 4. This is 4, and 1 2 3 4. This is 5 1 2 3 4. That is our 6. Okay, so this will be our 6. That is our 6 meters. Okay, first we have to plot our E is equal to Y. So if E is equal to 1, Y also is equal to 1. So that is the point. When E is equal to 2, Y is also equal to 2. Then when E is equal to 3, we also have Y is also equal to 3. Okay. We have only to estimate the points. Then if we draw the straight line for this, Okay, this will be 45 degrees, and this is your line, which is your energy, specific energy is equal to the depth of flow, y. Okay, next we have to show clearly, no, to have a good picture of the plotting of the equation of the curve using the equation of the specific energy, which is equal to E is equal to y plus v squared over 2g, and that will be equal to y plus q squared over 2g y squared. So this will be now equal to y plus, that is 0.319. Okay, 0.319 over y squared. We have to tabulate this. Okay, we have E. So we have y and E. So we have, if y is equal to 2.5, so we have 2.5 plus 0.319 divided by 0.25 squared. So we have, okay, 5.354. Okay, so if y is equal to 0.5, so we have 0.5. Okay, we have to substitute it to this equation. We have 0.5 plus 0.319 divided by 0.5, and that is equal to 1.776. Then if y is equal to 1.0, so 1 plus 0.319 divided by 1, that is equal to 1.319. If 1 is equal to 1.5, so 1.5 plus 0.319 divided by 1.5 squared, that is 1.642. Then when y is equal to 2 meters, that is 2 plus 0.319 divided by 2 squared, that is equal to 2.08. When y is equal to 3, 3 plus 0.319 divided by 3 squared, and that is 3.035. So we will use these points, okay, these coordinates, to plot for our specific energy. So okay, we have here, when y is equal to 0.25, E is equal to 5.354. So when y is equal to 2.5, okay, I have to, okay, 0.5, and that is 5.354. So that is 1, 2, 3, that is 0.5, maybe it's in here. Okay, we have only to estimate the points location. Then when y is equal to 0.5, so we have E is 1.775, that is 1.55, more or less, it's here. Okay, so we have here at this point. Okay, then we have also the, if y is equal to 1, you have is 1.319. So if you have 1, 1.319, 2.5, so more or less it's here, 1.319. So we have that one. When y is 1.5, so e is 1.642, 1.5, okay, that is 1, 2, 3, okay, there. Then 1.642, 1.642, okay, 75, more or less it's here, okay, more or less this is the location of the points. When y is equal to 2, e is also equal to 2.08. Y is equal to 2, okay, 2.08, more or less it's here. Okay, so more or less it's here. Then when y is equal to 3, it's also equal to 3, so more or less it's here. So it's here. Okay, that is 3.035. Okay, we also have to plot our critical depth and the minimum energy, or the critical energy. So this is also our critical energy. So when the critical depth is 0.86, E is 1.29. Okay, 0.86. Y is 0.86, 1, 2, 3. So more or less it's here. So I have then you have 1.29. So more or less it's here. Okay, 1.29. So here is your YC. This is 0.86 meters. And the specific energy or the minimum energy and the critical energy is equal to 1.29 meters. Okay, it's here. So if we are going to plot this, okay, we have this one. Now, what is the best color for this? I guess I have the black one. So maybe okay, we have to check again when y is equal to 1, when y is equal to 1, 1.319, 1.319. So 1.319, 1.29. So I guess we have this one. We have to move this one. This is 1.3191. Okay. Maybe the location of our E, that is 1.29. So more or less it's here. Okay. So I have to move because this is a very important points. So maybe it's here. 1 point, that is 1.25. So we have this one. Okay, then okay, so okay, maybe I have to plot. I will use the red one na lang. Okay, the red one. So we have here. Okay, more or less it's here. I cannot make a good curve. So I have to. It's good to have to make it drawn to scale. So if y 1.5, that is 1.319, 1 to 1.319. So more or less it's here. It's good if you have to draw it drawn to scale. The figure is drawn to scale so that you can have a good plotting of your data. So it's okay. Okay, you have to understand my plotting. Okay, then this is the curve. Okay, so I hope you understand my curve. So this curve is the specific energy equation. That is the curve to G. That is the curve of our specific energy. Okay, so we need to find or to incorporate also our alternate depths. and that is 2.447 and 0.338. That is when Q is equal to 4 cubic meter per second. So for E is 2.5. Okay, let's see if E is equal to 2.5. Okay, 2.5. Okay, 2.5. So this is our E. No? If E is equal to 2.5, for a given Q, so the alternate depths are 0.338. So if we have to get this one, this is the 0.338. This is your Y, which is 0.338 meters. And the other one is 2.447. 2.447. So 1, 2, 3. I have 2.447. So more or less it's 2.445. So more or less it's here. No, my curve is not so good. More or less your 0.447 Y here is 0.447 meters. So it's good that if you drawn it to scale, so that you will know you have a good curve, and it's better you have a drawn to scale for your figure. But this is just an estimation, and I just wanna to let you see how we are going to plot all of these points. So here, this is now all our depths of flow are plotted. So if you can see, for a given specific energy and for a constant Q, okay, Q, which is equal to 2.5 cubic meter per second, we have two depths of flow here, and that is 0.44. Sorry, that is 2 point. Okay, that is 2.447. I don't know how I write 0.44. Okay, so that is 2.447, and the other one, and that is at the upper stage, and the other one is at the lower stage, which is 0.337. As you can see also in the graph, the minimum energy or the critical energy is at the tip of your curve of the specific energy equation, which is E is equal to Y plus V squared over 2G. So this is showing that the minimum energy is at the tip of the curve. So this is a very good example how to illustrate of our topic, which is alternate stages of flow. And I hope you understand, and thank you also for watching my video, and God bless. Thank you again.